So we had MP4 and MP5 for CP2, and MP4 is model with mathematics. So this, I saw it as more like modeling an example for students, and then like allowing independent work or partner work or group work or whatever, but showing them at least a model of how to do it, of how you want it done, and then they can work with that. MP5 was using appropriate tools strategically, which was in our CP1, which is like technological tools, so like iPads or the smartboard, or maybe allowing different uses like laptops or computers to follow along the lesson or along with the student. So Pythagorean theorem continued, right? An elementary example. How can you solve for C using our multiplication facts? So this would be like kids in elementary school are learning 3 times 3, 4 times 4, 5 times 5, 5 times 3, 5 times 4, all their 5s, all their 3s, all their 4s, and stuff like that. So this would be a good question to get them thinking about their multiples and their multiple facts and their multiple numbers that they know, that they actually know, right? So the example we chose is like a 5th grade level. So first, with the kids, I would identify what we know, which is the formula, which is a squared plus b squared equals c squared. Second, I would review that exponents means twice or 2 times, or that number 2 times, right? And then third, we would plug in numbers into the formula. So we know 3 and 4 equals c. Next, we would keep the formula 3 squared plus 4 squared equals c squared, but the kids then will know 3 times 3 equals 9, and 4 times 4 equals 16. And they know 16 plus 9 equals 25. At a 5th grade level, they would be able to solve this. They would then move on and get to the hard part, which is the square root. I know this could be hard for elementary because they may just recently had it introduced when they had the exponents introduced, or maybe they don't learn the square root. Maybe they learn it a different way, like the opposite. I'm not sure. But this is where they would see the square root of 25 is 5, which makes c equal 5. C equal 5 feet. I would emphasize the units, even though I didn't have them on there, but I would emphasize that units are important when answering problems or answering problems on tests. For now, a high school example. How can we solve this real-world problem using Pythagorean theorem? The problem is, so I would have an actual problem for them, and I found this on a website. So Layla's school is having a door decorating contest. Layla's class wants to use ribbon to divide their door into 2 triangles. They know the length of each side of the door. To find out how long the ribbon needs to be, they can use the Pythagorean theorem. Okay, so this is the problem. And then I would go through what would we do first, right? Which would be draw a model. So here's like a model that I would draw, or that I would have the kids draw, and maybe someone come up and like show what they drew. And the door is 8 feet by 6 feet. I know it didn't say that in the problem, so maybe I would add that into it. Like the door is 8 feet, the bottom is 6 feet, the base, and then the length, or something like that, because it wasn't in the problem, but I would have probably incorporate that. So the procedures would be, so first draw a model, then second get the formula, so what we know, so a squared plus b squared equals c squared. Then third would be plugging in what they know, right? So this would be like a 9th grade class, like a beginning intro, like reviewing probably middle school stuff. So 8 squared plus 6 squared equals c squared, right? Then the students know 8 times 8 is 64, and 6 times 6 is 36, and they know they have to add them, and 8 equals 100. And then at the end right here, I added, what do you do next? Like, it's a way of me not giving them the answer, so I could see if they all know the answer, if they all actually do know the answer. So then I would ask them to like share with a partner, or or yeah, share with a partner or share with a group table. And then so what they did on their own would be the square root. So square root of 100, and then their answer would be the ribbon needs to be 10 feet long. So then they would have solved it. Right? And then in the model, I made sure to make a right angle so they can see how the ribbon is a hypotenuse and how the ribbon is the missing link we need to find, because I know that is important, and the right triangle needs to be identified.